Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into the second half of the prep of how to calculate z-scores and how to use the z-table to calculate certain percentages of probabilities given a normal distribution of data. So, in the first video here, I did example one, parts A, B, and C, and now we're going to do part two. Okay, so if you haven't done part one, you better pause the video, go back. All right, learn the first one here. So let's get started. Here we go. So example two, suppose we have a normal distribution of data where the population mean mu is 78. Okay, I'm just going to record this over here. Always do that. Off to the side, and we got a standard deviation of 4. Okay, so sigma is 4. All right, find the percentage of scores less than 60. Well, you write that as P for percentage or probability here of the score less than, keyword less than. All right, 68. That's how you write it mathematically. So how do you do that? All right, so the first thing we do, as I did with all these other ones here, is we draw a normal distribution and we kind of take a look at it empirically first, all right, and then we use the details. So, all right, so let's go off to the side. Let's draw a bell curve, a symmetrical bell curve. Okay, it doesn't have to be perfect, it just has to, be good enough for to see what's going on, right? Okay, split the bell curve in half at the mean. All right, the mean is 68. Oh, excuse me, 78. All right, 78. There's the mean called mu in the Greek system here. And what we want to do is find the probability, all right, that the percentage of scores is less than 68. All right, so 68. Let me see. So it's way, way over here. So let's say 68 is here. It's a little sketch. All right. And what we want to do is find this little percentage here. It's probably going to be small because 68 is multiple deviations to the left. All right. So what we're going to do is calculate the z-score first. All right. So z is equal to x minus mu. All right. Divided by sigma. Then it's score minus the mean. Score minus the mean divided by the standard deviation. Okay, so in this case, it's 68 minus 78 divided by 4. What do we have there? We have a negative 10 fourths. That's negative 2.5. Okay, just do the arithmetic here. And again, you bring in decimals here. Obviously, divide negative 10 by 4, and you get negative 2.5. So use your calculator when you need to here. And then, of course, you use the z-table. So let's do a little sketch of the z-table first. These are the z values here, and negative, if z is equal to negative 2.50. So you put the first two digits here, negative 2.5. All right. You put the hundredths digit up here, and it's 0. So 0.00, hundredths. Right? And then what you do is you go across, you go down, and you read that number. Okay? That's how you use the z-table. And z-scores are always rounded to the nearest tenth if necessary. Okay? So let's make a little note of that. Round to the nearest tenth. Didn't have to this time, excuse me, nearest hundredth. However, most of the time you do. So two decimal places there, guys. Okay, I'm going to say always. All right, so a little key note for z-scores. Z-scores. All right, so let's go to the table, find negative 2.5, and let's go for it. Now, z-tables have the positive side for positive values when you're greater than the mean, and you have negative z-scores if you're lower than the mean. So you got to find negative 2.5. All right, so it's right there. Okay, z equals negative 2.50. And then you go up to the top here, which is 0. And then you go down, and then you go across, and you read the number 0.0062. It's small. Okay, so here we go. Let's go 0.0062. Okay, so 0.0062, multiply that by 100 to change it to 8%, and you get 0.6. Okay, not 6, 0.6%. This is less than 1%. It's very small. And that, my friends, is this right here. This is 0.6%. So my answer here, okay, this is not really drawing to scale. It's actually smaller than that because this is over 3 deviations to the left I mean, excuse me, almost 3 deviations to the left, all right, is going to be equal to 0.6%. 0.6%, less than 1%. So this is a very small number there, guys. Okay, and that's the first one. Number two, find the percent of scores is the least 84. Okay, so mathematically, we write it as this: find the percentage p that the scores is greater than or equal to. Okay, so we're doing one of the least here, 84. Okay, so let's see how many deviations to the right it is. So uh, let's add sigma 4 multiple times. So one standard deviation, 78 plus 4 is 82. So that, again, this is plus 4. And let's go add 4 again. Okay, again, sigma is 4. And the problem here, 82 plus 4 is 86. Okay, and 84 is in the middle. Okay, so 84 right there. All right, so we're between z equals 1 and z equals 2. Okay, so I'm expecting 1 point something. All right, so, oh, you know what? I just did that on the previous distribution. I shouldn't do that. Okay, let's redraw it down here. Okay, so let me redo what I was just saying because I went a little bit too fast here, guys. I used the previous diagram, which is okay, I guess. All right, but let me just repeat what I just said. I'm going to use the standard deviation here of 4 because remember, sigma is 4, the mean is 78. Okay, so if I add 4, I get, you're at 82. Okay, you always add the deviation to the right, plus 4, and then plus 4 again is 86. So where's my value of 84? It's right here in the middle there. So we're between z equals 1 and z equals 2. We don't know if it's in the middle, guys. Okay, you can't assume that. It's not exactly in the middle. Okay, because this is a bell curve. Okay, it's not linear. So be careful there. Don't assume it's 1.5 because it's not. So let's calculate it here. So it's always the score minus the mean, x minus mu, all right, divided by sigma. So 84 minus 78 divided by 4. All right, so 84 minus 78 sounds like 6. 6 divided by 4 is 1 and 2/4, 1.5. Well, look at that, it's in the middle. Well, how about that? Okay, so let's figure it out. Okay, so what I want to do is look for 1.5 up here, 0.00 here, go across and down. Okay, across and down, x equals 1.5. Yeah, I'm just double checking my arithmetic here. Yeah, I think it's right. 84. Yeah. Okay, looks good. Okay, so what we want to do is let's highlight the area that we're trying to find here. So trying to find the scores that are greater than 84. Now 84 is here, so let's highlight it in first. Okay, so I'm trying to figure out what that area is to the right of 84. Okay, to the right, not to the left, but to the right. What would that be? Well, let's figure it out. We got to go to the z table here, find 1.5. So let's do that. So 1.5 is here, go across and down. No, 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 down right here, 0.9332. Okay, so 0.9332, which is equal to 93.32%. Okay, now what that represents is the area to the left. Okay, so the z tables always give you the area or percentage to the left of a certain value. So let me highlight that in, this right here. Okay, all of this right through. This is what we just found, okay, using the z table. All right, so let's take that. Let's bring it over here. This is 93.32%. To the left, okay, to the left is 93.32%. To the right, well, you got to subtract that from 100. Okay, so this right here, this is 100% minus the 93.32. Okay, so 100% minus 93.32%. What does that equal? Well, let's bring it in. All right, so we take 100, 1 minus, or subtract 93.32, get 6.68%. 6. 6.68%. There we go. All right, and that is how it's done there, guys. Just have to remember that Z tables always give you percentages areas to the left, not to the right. So this takes an additional step as compared to the first one. All right, so keep that in mind. Now the third one. Okay, the third one. Let's find the percentage scores is between 70 and 83. So here, okay. So let's draw a picture first. Going to draw a symmetrical bell curve. Okay, put the mean in the middle. So remember, the mean in this problem is 78. Standard deviation is 4. So split the graph in half. Put the mean in the middle, 78. Getting all carried away right there. So mean, okay, that's mu. All right, standard deviation of 4. So let's find 70. So I'm going to go to the left. So subtract to the left. So we get 4. Go 2 deviations. Subtract 4, and you get 70. Well, look at that. It's 2 deviations to the left. All right, and now let's find 83. Go a deviation to the right. Okay, one standard deviation to the right, you're at 82. One another one, you're at 86. So 83 is a little bit bigger than 82, so 83 is right about here. Okay. Okay, so now we located 70 and 83 in respect to the mean. Now let's draw uh, some areas here. Okay, so if we can find, okay, the percentage of the students less than 70 in the table, that's pretty easy. That's in yellow. Okay, so we need to do that. So here, this is the percentage of students less than 70. Okay, and then we can find the percentage to the left of 83, the percentage of the scores less than 83. That's this one here. Let's shade that in a different color. So let's go with green right now. Okay, and that's this one here, this big area. Okay, this big area. Okay, and that's the green one right there. But what we want, okay, is neither one of those two. We want the percentage that's between 70 and 83 in the blue. This is what we want. Okay, so how do you write that mathematically? So let's do that. So the percentage of the scores that's between 70 and 83 is written as a compound inequality. So the keyword is between. And that, my friends, is in the blue area. Okay, blue. So how do we do that? Well, we take the green and we subtract the yellow to get the blue. Okay, so that's the concept here. So we're going to take our green area. So you know what? I'll just draw this a picture. This is straight from geometry. So you take the green, the big one, all right, minus the yellow, minus the yellow area, which is small, this little piece right here, this little piece right here, and you get the area between them, which is the area of blue. Okay, so the small minus the big, or excuse me, the big minus the small. So the probability or the percentage that the scores are less than 83 minus the percentage of the scores that are less than 70. We figure those two things out and we got it. Okay, you just subtract the two. So we got to do some Z table work here. So let's do that. Z scores. Okay, so Z is equal to, let's see, let's do 83 first. So 83 minus 78 divided by 4. Okay, then Z is equal to, let me see, 83 minus 78, that's 3, and Z is 5. So 5/4. Okay, and then if you, well, that's 1 and 1/4 and 1.25. But if you didn't know that, you take 5 divided by 4, you get 1.25. 1.25. And then, of course, you go look on the Z table and you find 1.25. So 1.2 here, 1.2, 0.05 here. Again, the first two digits of your Z score in the column, and then you put the hundreds place, which is a 5 hundredths up there on the first row in your Z in your column. And then you look down and across, or across and down, and you read the number. All right, so let's go to the z table and find 1.25. Okay, 1.25. So let me pick a different color here so you can see. So 1.2 is here, and 0.5 is here. You go across and down, 0.8944. Okay, 0.8944. 0.8944, which is 89.44%. It's big. Why? Right? Because, all right, well, because it's a big area, right? So just look at it geometrically, it's the biggest one, right? It's almost the entire bell curve, right? Now we got to get the other one. All right, so z-scores first. So 70, always score minus the mean. 78 divided by the standard deviation, and that's a negative 8 divided by 4. We knew that was 2 deviations away, so negative 2 makes sense. All right, and then if you look at the table, you put negative 2 here, negative 2.0, 0.00, and go across and down, and then you read the score. So we got to go to the negative side of the z table this time, find negative 2, and we already did that before, it's in red. Okay, so that's 0.0228, 0.0228, 0.0228. That's a small probability or percentage. So this one right here is 2.28%, or in here, 2.28%. Very small, okay? Okay, now all we do is subtract them, right? Big minus small. So in red, here's our answer here. Here we go. So we're going to take our 89.44%. We're going to subtract our smaller percentage, 2.28%. All right, let's bring in the little Desmos action here. So 89.44 minus the 2.28. All right, you get 87.16. 87.16%. And that, my friends, is the blue area. Okay, so 87.16%. Right there. That's the that's percentage of scores, right? That are between 70 and 82. All right. So all you do is do big minus small. All right, and you get the area between. There we go. And that is the three cases. Okay. So I just worked through them all to help you guys out because there's a lot of stats. You may have not gone through this before, and it's how you use the z-table and the z-scores to calculate certain percentages and probabilities, given some normal distribution of data, whatever that may be. Okay, so I broke it up into a two-part video series because there's a lot to do. So video one goes over example one, and video two goes over example two. So hopefully that helped you guys out. Work hard, get some skills, and I'll see you in class.